Hi, everyone. Hi. So, test tomorrow. Let's go over some stuff, right? So, 10 questions, still 10 questions. I would say that 7 of them are very easy. Maybe not very easy, but very doable. Probably 4 of them are very easy. So don't make silly mistakes. Showing all work on there will help. They're not 10 points apiece. Most of them are 10 points apiece. Some of them are 10 points apiece. I should probably start this video over. I'm not going to. But if you show work and like you pick the wrong result on a couple of them, like if you pick the wrong choice, but you show the complete work, I'll give you at least half credit, maybe a little more, right? So we'll see how it goes. All right, so I gave you, or I put the answer key to the first 2 or 3 pages from the review on eClass yesterday. I'm gonna do the key problems on that final sheet that I couldn't find the answers for. Now, there are 5 questions on that page. Number 4 has no relevance to our test tomorrow. The other 4 problems do. So number 4 doesn't matter. The work done by a crane, that's not important. So let's go in order of what we know, right? Because we didn't do a whole lot of work problems. I don't think we did any, but it's really super simple. Let's do the airplane problems first. So I'm actually gonna be looking at number 2 on that sheet, right? So let's see what we got going on here. So number 2, and I can't write the whole thing obviously because it's way too much, but it says an airplane has an airspeed of 430 miles per hour at a bearing of 135 degrees. Says the wind has a velocity, which is just speed, of 35 miles per hour, and it's in the direction of north 30 degrees east, so like northeast 30 degrees, right? Find the resultant speed and direction. So we want the resultant speed and direction. Okay, so 2 huge ideas. Let's kind of decipher what is happening first, and then we can draw some pictures. So what we're really looking for is we want the magnitude. This marker's terrible. And direction, which is inverse tangent of y over x, right? So direction is that, I think I'm gonna make it from here. Off the desk, no, I tried. Okay, so we want the resultant speed, meaning we want the resultant magnitude of after we add these vectors together, and we want the direction, which is inverse tangent. So what are we doing here? We are adding vectors. And then we are going to find the magnitude of that final vector and the inverse tangent of that final vector. So this is what happens when we have a bearing and we have like 2 vectors. Like when we have 2 vectors, like one being wind speed and one being the whatever else, like the speed of the airplane, we're just going to add them together. So let's draw some pictures, right? So here's our coordinate plane. The airplane has a 430 degree speed, which is its magnitude, and bearing 135. Bearing means it's coming from the north, right? So 135 is gonna be about here-ish, right? Which is actually, this is 90 and this is 45. So this is a 45 degree angle, okay? Now, if you put 135 there, that's fine, but you wanna kind of put it into the same directionality of what the unit circle will be. Now, again, if it's 135 degrees, bearing from the north, it's gonna be in this direction here because we're going from the north clockwise, okay? So 45 degrees, the magnitude of it is 430, okay? Which means that's the hypotenuse of this plane. So we need to find the x value and the y value, which is the components of that vector. But first, let's talk about the wind speed, because that's another vector, right? So the wind is 35 miles per hour, northeast, right? So north 30 east is just northeast. So no bearing there, right? It's just northeast 30 degrees. So 30 degrees. Right. So there's no, it didn't say bearing. So when it doesn't say bearing, then it doesn't matter. So we've got a 30 degree wind speed, or we got a 30 degree angle of the wind speed at 35 miles per hour. Okay. So we have 2 vectors here, right? We've got the vector of the wind and we've got the vector of the plane. When we have 2 vectors, remember what I said, we are adding vectors together. So what are these vectors? We need their components. We don't have their components. So to find their components, I'll go back to the blue function first, or the blue vector first. We're going to use some old school SOHCAHTOA to help us. So we know the angle of 45, we know that the hypotenuse is 430. So to find x is going to be cosine of the angle, which is going to equal x over 430. multiplied by 430 on both sides, and then you can just put it in the calculator. To save some time, because this is already a 5-minute video, I'm just gonna go ahead and do that. And then we're gonna do sine of 45 equals, I'm gonna put y there, of 430, okay? Now, if it's a 45-degree angle, that means that both of those values are gonna be exactly the same, right? One will be negative though, because our y value was going down, right? So I got the component of our first vector was 304.1 comma negative 304.1. And again, it's negative because this y value was going downhill because this was in quadrant 2. That's our first vector, the vector that represents the airplane. Now, we want to represent a vector of the wind. Same idea. So for this particular one, and I don't know if you can see this, but hopefully you will be able to. Ooh, that's not gonna stay. Okay, so for this one, we're gonna do the same thing. We're gonna do cosine of 30 degrees is gonna equal x over 35. And then sine of 30 degrees is going to equal y over 35. Okay, and again, I would just multiply by 35 on both sides to get those values. I'm going to get here for this component 30.3 comma 17.5. Now, there was no change here with signs because remember, this is in quadrant 1, so both x and y are positive. Okay, so now we have our two vectors in component form. We are adding vectors together. So I'll add them and I'll put it over here a little bit. Hopefully you can see that. Okay. So, and again, I did this beforehand. So, okay, when we add those vectors, we're just adding the x values and the y values together. So we're gonna have 334.4 comma negative 286.6. That is the resultant vector in component form. So that means that we are, I don't really want to do this, but let's just say here, right? So this is 334.4. Ooh, it's in the other quadrant, sorry. Because it's negative. So 334.4 and negative 286.6. Okay, so this is my x and this is my y. So we need to find two things, right? It asks us to find the magnitude. Well, I'm just going to put this into Pythagorean theorem and solve for the magnitude. So the magnitude or the speed of the airplane, remember we're going to do this, it's a squared plus b squared equals c squared. So the magnitude is 440.4 miles per hour. Okay? So again, when you put that in Pythagorean theorem, that's what you're going to get for the speed. And we want to find the direction. Now direction is going to be a little funky here, right? So when we find direction, remember we're doing inverse tangent of y divided by x. Well, when I do that, I'll actually do that again because it's interesting to remember. So if I do inverse tangent of this, it's going to be opposite over adjacent. So negative 286.6, we don't have to put the negative because it's going to change anyway. Divided by 334.4. Okay. That's negative 40.59. Okay, so we would get here negative 40.59. But the problem with direction is that there's rules. And we talked about these rules a little bit. When they're in a certain quadrant, we have to do different things to them. Well, because this is in quadrant 4, we're going to subtract 360 from this, or in this case, add 360 because this is just a positive value anyway. Your resultant direction is going to be 319.4 degrees. So this is my final values. The magnitude or the speed of that airplane after all this is done is 440.4 and the direction is 319.4. Okay, so the other problem on here that's just like it is number 3. Okay, so see if you can get that one and I'll put the answer on Remind so you can get that. So what did we do here? We had two vectors. First, we drew them because we needed their components, meaning their x and their y values. Then we found the addition, or we summed them together to find the summary or the resultant vector in component form. Then we graphed it, and we were finding the hypotenuse, which is the magnitude, and then we found the direction, which is inverse tangent. Okay, so that is the plane problem. Now, for the other problem, the work or the force problem, this is actually way easier than you think. Sorry for the length of the video. Okay, so I'm going to be looking at, I guess the easiest one is number 5. Now, number 5 is a work problem. So it says one of the events in a local strongman contest is to pull a cement block 100 feet. Okay, so we're gonna pull the block 100 feet. That's distance. Okay. A force of 250 pounds was used. Okay, so force is 250. Okay, so we have distance of 100 and force of 250. And then the angle was 30 degrees that the block was pulled up, right? So then the theta measurement is 30. Okay, well this is gonna be on your test tomorrow. The formula for this is work equals force times, now it says V, but V just means distance. It really means displacement, but we don't have to worry about that. Times cosine of theta. This is the formula to find work. So it's like I said, it's really simple. So to find work, you need three things. You need the angle that it's being pulled up or down or dragged. You need the force that's exerted, and you need the distance, or which is called displacement, which is V, right? So we're gonna do, literally, we're just gonna multiply all these three numbers together. So force was 250. The V, which is distance, is 100. And we're gonna do cosine of 30. So I had done that, I think. No, I didn't, okay. So 250 times 100 times cosine of 30. Okay, so the force, and it's gonna be a big number. The force, or the work, sorry, that is exerted is 2165.0.6. That's the work that's required to pull that block 30 degrees, so put 100 foot, whatever, okay? So again, what are we doing? You need to find three pieces of information, or you need to be given it, and you will be. You're gonna be given what the angle is, what the amount of force is necessary, and then how far is it going? And you're just using this formula, which again will be on your test tomorrow, okay? Last one is a blast from the past. We're gonna draw it because it'll make more sense if I draw it. It's number 1 on the sheet. So forces with magnitudes of 85 pounds and 50 pounds act on a single point. Okay, so we got two forces, two different forces reacting on a single point. The angle between those forces is 15 degrees. Find the resultant force. Well, if you draw this, it's gonna make a lot more sense. So I've got magnitudes, meaning hypotenuses, if you will, acting on a single point. So I drew those really bad, I'm sorry. This was the converge on one point. So one is 85 pounds and one is 50. They're coming to one point. And the angle between those two forces is 15 degrees. Find the resultant force. Well, what does this kind of look like? Well, it looks like a triangle. Good, I'm glad you said that. This is the resultant force. I need to find X, meaning I need to find the combination of those two things. But if this is a triangle and you have these numbers or these values in that particular order, we've done something this year that actually helped us solve that. And, oh, thank you, yeah, you said it, law of cosines, nice job. So you're actually gonna use law of cosines here, right? So to do this, our law of cosines is gonna be, I'm trying to find the side. So we can just say c squared, it doesn't matter. That's gonna equal a squared plus b squared minus 2 times a times c, b, oh my gosh, b times cosine c. It's time to go. Okay, so a and b, it doesn't matter, right? A, b, and this is c, cosine c. So we'll do c squared equals 85 squared plus 50 squared minus 2 times 85 times 50 times cosine of 15. Now, I think I had done that one. No, I didn't do that one either. I'm terrible. Aren't you happy you've spent 14 minutes with me? Okay, so we're just gonna put this whole thing in the calculator. And now remember, we're gonna have to square at the end. So 85 squared plus 50 squared minus 2 times 85 times 50 times cosine 15. Okay, so we are gonna get c squared equals 1514.630477. We're gonna square root that answer. And we're gonna get 38.9. And that is the resultant vector, or the resultant force, okay? So basically, we have to use the law of cosines in order to do this. And you're gonna have a problem that's very similar to this. So here's what we'll do. On remind, I'll put down 2 different problems, one like this that you need law of cosines for, and one about the work from earlier, like the work problem. One more thing for my group, unit vector, we talked about this, but it was brief. To find a unit vector, it's so simple. I just need you to see it. You probably could figure it out on your own, but I'm gonna just show you. If it says unit vector, it just means a unit of 1. So I'm gonna give you directionality, or I'm gonna give you a vector. Let's say I give you the vector equals 7i plus 4j. Okay, so if I want the unit vector, here's what we do. It's going to be whatever a is over the magnitude of the vector, plus or minus whatever b is over the magnitude of that vector, right? So this is a unit vector. It just basically puts each individual portion or component over the same magnitude. I don't know why it's like that. That's just the way it is. So if I want the unit vector of this component form, a is 7, right? So this is going to be 7 over the magnitude, which I'll do in a second, plus 4 over the same magnitude. It's the same thing, right? So the magnitude of this is the square root of both these things. So it's going to be the square root of a squared plus the square root of b squared. So 7 squared and 4 squared. So 49 plus 16, right? So it's going to be, what, 65? So the magnitude of this component is the square root of 65. So we're actually just going to put the square root of 65 under both of these. And that's my final answer. So again, to find a unit vector, it's going to be given to you in some kind of component form. It's whatever the a value is, meaning x, right, over the magnitude of that vector and over b, plus or minus b of that vector. 17 minutes.